We noted at the end of the last video that we're going to use the point estimate of p hat in this section, which is x over n. That sample statistic we're going to use to estimate the population proportion p. So how we do that is with this formula right here. This is the confidence interval formula for a population proportion. And the formula itself is right here. It's p hat plus or minus z alpha over 2 square root of p hat times 1 minus p hat over n. Now some of this should look familiar. For example, we've already learned what p hat is, and it's the point estimate because it's your single best value guess. So it's the one number that is your best guess for where p is. So you use p hat, which is a sample proportion. Z alpha over 2, we saw just a touch of a little bit in chapter 7. We called them critical values even then. So it's the Z score that has alpha over 2 as the area in the right tail. We learned that at the very last bit of section 7.2. And then this big huge square root thing, we learned in chapter 8 that that is the standard error for p hat. So it's all starting to come full circle at this point. So this is the formula, and if you look at your note sheet that you'll get on your exams, which is the packet in the back of your course pack, you can see that I don't expect you to memorize this formula because all that information is in a compact form right here. It says one sample proportion, that's the type of interval we're doing. It tells you about one prop z int, that's where we're going to go on the calculator to get it. We'll talk more about that later. There's the formula in the little box. There's the point estimate part, p hat, which is x over n. And then there are the three requirements, and those come right out of section 8.2. If you look at the notes for 8.2, if you look at the central limit theorem for the sampling distribution of sample proportions, this is what you have as the three conditions that are required in order to meet or in order to have that central limit theorem, which is where this big square root guy comes from. All right, so we need to be able to take a moment and remind ourselves how to find those z alpha over 2's because they're part of this formula. So we're going to spend a page trying to figure those out. So we'll figure those out. Before I head there, though, just remember that these requirements came from Chapter 8, Section 8.2 in particular. So these are from Section 8.2. And then we have the margin of error, which is the back end of that formula. Margin of error is the part that you add on or subtract away from your p hat in order to find how big your window is, because we're building essentially a window for where we think p is going to fall. We don't know where the population proportion is, but we think it's somewhere close to p hat. How close is what this is, right? This is your margin of error. So it's what you add on and subtract away. And sometimes it's easier to find with the formula, and sometimes it's easier to remind ourselves that it's half the width of the interval. So we'll sometimes use the formula above, and we'll sometimes use the half interval width, whichever is more convenient. And just a little z values in each of the following cases. I'm going to show my work, label my picture, all that good stuff. So I'm going to find the critical z values for a 95% confidence. Well, remember, if you have the middle being 95%, that means that there's 5% left over for the two tails. So let me paste that, or copy and paste that in. All right, we start off by noting that the alpha and the C level are complements, and you can see that up in the formula box. Oh, I shouldn't have scrolled this way to get to it. Sorry. I'll have to use the formula sheet for future. But you can see right here, it says the 1 minus alpha times 100% interval. And that tells us that alpha and the C level, the confidence level, are complements of each other. They have to add up to 1. So once I know it's 95%, then I know that alpha is 1 minus that. Okay, so that tells us that alpha is 1 minus 0.95, which is 0.05. That'll automatically be the area in both tails. But we're doing a confidence interval, so we want alpha over 2 because we want to split it up. So I'm going to take alpha and I'm going to cut it in half, and that's going to get me 0.05 divided by 2, which is 0.025. That will be the area in each tail on its own. And you can see that I've drawn the curve, I've shaded it. I don't know what z's are, so I'm putting little question marks down there, but I put little arrows and I've labeled each side as alpha over 2, 0.025, and I've got the middle labeled as 0.95. You have to do all of that. You must shade, put the area either in the curve or above the curve with little arrows. Label your negative z, your positive z. All this has to get labeled down here. Okay, so then what are those negative z alpha over 2 and positive z alpha over 2? Well, we have to find that with inverse norms. So let me pull up a calculator. Let me remind you about inverse norm. It's above the distribution menu. So if I look at number 3, inverse norm, and I want the left tail area, so I'm going to go 0.025. That's what the area in my left tail. And of course these are z-scores, and we learned in chapter 7 that the z-curve has a mean of 0 and the standard deviation of 1. So I'm just going to go down here to paste and press enter. And I get negative 1.96 roughly. But that means that the one on the left is negative 1.96. So the one on the right is positive 1.96. And I have my work here. So I show my work by just showing what one of my calculator entries was. And my answers are right here. Z 0.025 is plus or minus 1.96. And those are my final results. All right, now let's do it again. So here it wants the critical values for a confidence interval if alpha is 0.005, and then what confidence level would have that critical value. So I'm kind of reversing it on us. Instead of giving us confidence, which I did here, I'm giving us alpha, and then I'm asking for the confidence. So again, we note that alpha and the confidence level are complements of each other, so that's useful to know. That means that since alpha is 0.005, alpha over 2, which is what actually goes into the tails for confidence intervals, is half of that. So I take 0.005 and I cut it in half, and I'll get alpha over 2 is 0.0025. Now it's important to notice this is not the same question as the one above. The one above has alpha over 2 being 0.025, only 1 0 in there. This one for letter B has 0.0025. So it should be farther over, but I'm not drawing these to scale. So I just have this picture, but I've labeled them 0.0025. So they're really tiny tails. Very, very, very small. Smaller than I have shaded here, to be honest. All right, now what's the confidence level? So that's my next question. So it wants to know the confidence level. Well, the confidence level is the complement of alpha, so that's actually a really easy question to answer. All we have to do is take 1 minus our alpha and we'll have our confidence. So if I take 1 minus 0.005, I have 0.995, which means my confidence level is 99.5%. All right, great. So then all I have to do is find the score. So I've answered one of the questions, but now I actually have to find the critical value. So I'll do that one in yellow, which I should have done up above. So they want the critical values. So find the critical value. So I found the critical value. Letter A was only asking for that bit. It wasn't asking for anything else. So I found it. All right, so let's think. I need a calculator. I'm going to go to inverse norm again. So I'm going to go to inverse norm, but instead of 0.025, I'm going to put in 0.0025. 0 and 1. and leave it at left and paste. And you can see that's much farther over. That's negative 2.8. So 2.8 standard deviations away from the mean. So that's that answer. And then, of course, the final result will be plus or minus. So you show this inverse norm to show your work, quote unquote. That gets you one of the answers. But the final result is actually the two answers put together. They're the critical values. All right, last but not least, let's find the critical value that would cut off the top 6.5% of all scores. So this is a little bit of a trickier question. So we have the top 6.5%, but because this is a confidence level given to us, we know that this is automatically an alpha over 2, because if you scroll back up, you can see the only pictures that happen for confidence intervals, which is the only type we're dealing with right now, has to be that the right tail is alpha over 2. So I know that alpha over 2 is 0.065. So I can use that fact to find alpha, and then I can use that to find my confidence level. I'm sorry, having some scrolling issues. So the first thing I did was I wrote down for myself, look, that alpha over 2 must be 0.065. That is the area in each of the tails. So it's not only in the right tail, but it's in the left tail. So I can add the two of those up, and I can figure out what the two tails together would be, and that would be 0.13. So this is both tails together. And then I can say from there that the confidence level is 1 minus that. So this is both tails together is 0.13. That's what alpha would stand for. So then the confidence level is 1 minus that. So it's 1 minus 0.13, which is 0.87, which is 87%. So I know that my center is 87. Now if you do this right, these three decimals, well, there's a couple of things. The left tail and the right tail should be symmetric, so it should be the same number, same area on both sides, and they both should be labeled. And then you should label your interior as 0.87. That's your confidence level. I can't stress enough, you absolutely must label and shade these graphs appropriately. You have to put your Z's down in an appropriate spot. You have to label and shade everything. Areas get labeled above, Z-scores and the mean of 0 get labeled down below. It has to look like this. You cannot skimp on that. Okay, so now how do I find what these scores are? Well, I can find the one on the left really easily. So the one on the left would be inverse norm, but 0.065. So I can do to distribution, pick number 3, inverse norm, say 0.065, go down to the bottom to paste, and there I have it. So I know that the one on the left is negative 1.5. That means the one on the right is positive 1.5. And that's actually what they were looking for. They really wanted the top one because they asked the critical value that would cut off the top 6.5%. So they're really only looking for that positive one on the top, which is top z-score is all they're interested in, which is z.065, which is positive 1.514. So I used the calculator and I got the one on the left, but then I use my rationality, my logic here, and I think they're talking about the top top 6.5% right there, that top. That's a big deal, right? Because it's the top, that means that it has to be the one on the right that they're discussing. Now, if they said the bottom 6.5%, that would be negative 1.54. So you have to kind of look at the problem and see which context they're giving. Now, if they ask for both values, like they did here, critical Z values, plural, then you just give both of them plus or minus. Which, quite frankly, that's what we're going to do more often than anything else. So there they are, just in case I ever ask for them. If I want both critical values, it's plus or minus 1.514.